We're going to jump on into lesson 23, and there are only two parts, and they are based on the same thing. So 23.A is a review of exponential functions. And in exponential functions, your variable is the exponent. So that is why we call it an exponential function, because x is your exponent. Now there are two kinds, growth and decay. For a growth function, your base is greater than 1. In a decay function, your base is greater than 0 but less than 1. So decimal, fraction, and so on. A growth function starts out small and then it exponentially grows. That's what they said was going to happen to coronavirus, right? 5 cases, 10 cases, and then it becomes exponentially greater. Decay, the value starts out great and then exponentially decreases. Kind of like the value of our cars. As soon as we leave that dealership, it greatly decreases. In all of these, you do have an asymptote. In most of the cases, these graphs do create an asymptote where, and it is a vertical asymptote. For example, where the y value is approaching 0. So if I gave a bunch of examples, so here's some exponential functions, and we're going to use some of these. Y equals 2 to the x, or f of x equals 7.5 to the x, y equals 0.62 to the x, or y, I should change that, g of x equals 3/4 to the x. Now, these are both these bases. The base is greater than 1, so these are growth functions. These both have a base that has a value that is greater than 0. It's not negative. Okay, so the base is greater than 0, but it's less than 1, so these are decay. Okay, just a side note, if you have a negative base, it is neither growth or decay. Okay, and so if you're ever, and I don't remember if the book even gives you one of those, but just so you know, the base cannot be negative for it to be growth or decay. So I want to start with just the basic growth function. So we're going to graph the following. We're going to graph y equals 2 to the x, because these are kind of like the parent functions, and y equals 1/2 to the x. Now, please know that these are reciprocals of each other. So this is 2 over 1, and this is 1 over 2. So I want to show you what a table would look like, because it's super helpful. If you know what this looks like, then you'll know what the 1/2 looks like. So 2 to the x, I'm going to start with -2, -1, 0, 1, 2, and I'm actually going to go all the way to 3. So when building an exponential function, right, I know that when I plug this in, this is really 2 to the 3rd, which would give me 8. Right, 2 times 2 times 2. This would be 2 squared, which equals 4. 2 to the 1st equals 2. 2 to the 0th power, anything to the 0th power is 1. Now 2 to the -1st means I'm going to write the reciprocal. That would be 1 over 2. That's why it's so important to know how to simplify negative exponents. 2 to the -2nd, well, that would give me 1 over 4. So the graph of this function, and I think I have room for it right here. So I've got, I'm going to, okay, so I have -2 and 0.25, -1 and 1/2, 0, 1, 1, 2, 2, 4, 3, 8. So my graph should be really close to where y equals 0, and then it should exponentially increase. And here is the function, and you've got like this invisible asymptote at 0, and that's because the more negative my exponent, the smaller the decimal, so it's getting closer to 0. Now 1/2 to the x would literally be the reciprocal of the other table. So this would be if I flip So because this is a reciprocal, this is 1/2 to the x, it would be a reciprocal of 2 over 1, so the graph is a reciprocal. So I'm going to use the same graph, but I have to go to -3. And I want you, I've flipped the table over, and notice I'm going to flip my y values. So 8, 4, 2, 1, 1/2, 1/4. Okay, so 1/2 to the -3rd. I flip it over, right? And then the exponent becomes positive. So it's the y values flipped. Okay, so I hope you can see that. This is 1/2 to the -1st. This is 1/2 to the 0, right? This is 1/2 to the 1st. This is 1/2 squared, because 1/2 times 1/2 is 1/4. So notice I flipped my y values. Flip, flip. And then if I was to graph this one, whoops, it should be the reciprocal of a growth, which would be a decay function. So this one should resemble a decay. So here's 2, 4, 6, 8. Here's -2, +2. So at -3, I have 8, 4, 2, 1, 1/2, 1/4. And so now if you'll notice, the graph is the decay function because my base is 1/2. And you are going to be given a lot of these same ones. You're going to be given 3 and 1/3, 4 and 1/4, 5 and 1/5. And know that they're tables. The y values are flipped. Okay? So that is exactly what we're going to do in 23. Point B is just practicing graphing exponentials. So example number 2, graph f of x equals 5 to the x. Sorry, and I'll move the camera. And I'm trying to do this before our Google Meets, so I might go a little fast. So really quick, I only need a couple values. I'm going to do -1, 0, 1, 2, because this is a base of 5. So 5 squared, right, equals 25. 5 to the 1st equals 5. 5 to the 0th power equals 1. 5 to the -1st power equals 1/5. And when I graph that, I'm going to use a decimal. Now, because I have such great numbers, we can change our scale. Right, I could go 5, 10, 15, 20, 25. So we can change our scale. I'm going to keep the x-axis, though, by ones. Okay, so here's my y-axis, here's my x-axis. So negative 1 is barely above 0, right? Then I've got 1, 5, 25. So your bottom, whoops, as you can see, keeping our graph accurate. If you guys need a ruler, they're like 10 cents, okay? One more, so example 3 for today. Graph y equals 0.25 to the x. Now I'm going to rewrite this so that it has a fractional base. It makes more sense to me. So 0.25 is the same as y equals 1/4 to the x. And so my table should be the reciprocal y values of 4 to the x. Okay, if that helps when you build this. So x, y, -2, -1, 0, 1, 2. So I know that for 4 to the x, this would be 16, 4, 1, 1/4, 1/16. So this table should be a reciprocal of that. -2 should give me 16, 4, 1, 1/4, 1/16. Notice I've flipped my y values. Okay, another way to look at it, this is 1/4 to the -2nd. So I would write the reciprocal, 4 over 1, exponent becomes positive. This would be 1/4 to the -1st. This would be 1/4 to the 0, and so on. You could also literally use your calculator. But I don't like using my calculator if I don't have to. So if you want to use your calculator, you could put 0.25. Let me show you because I'm trying to wrap this up. 0.25 to the -2nd. And, sorry, see, it'll give you 16, which is what I got. So you can use a calculator if that makes you feel better about life. Okay, I'm going to change my scale. So 4, 8, 12, right, this was 16, 20. I'm going to keep my x-axes by ones. So -2 and 16, 4, see, that would be 1, 0.25, and so forth. Okay, easy peasy. So for homework for lesson 23, so homework 23, skip numbers 2, 5, 10, there's a few more. Here 2, 5, 10, 15, 16, 22, and 26. You're welcome.